Welcome to Sweet Dream Science, a gentle journey through the world's most magnificent peaks. As you settle into comfort, let these stories of mountains carry you toward peaceful rest. Close your eyes, breathe deeply, and let your mind wander through these ancient landscapes. Tonight, we'll explore 30 fascinating facts about mountains, each one a soft stepping stone towards sleep. There's no need to remember every detail. Simply let the words wash over you like a cool mountain breeze. Imagine looking down at our planet from space. If you could see through the clouds, you'd notice that mountains cover about 22% of Earth's land surface. These magnificent formations rise from every continent, even Antarctica, creating a network of elevated landscapes that shape our world in countless ways. Mountains aren't randomly scattered across the globe. They form in great chains and ranges, following the ancient movements of tectonic plates beneath Earth's surface. The Himalayas, the Andes, the Rockies, the Alps, each tells a story of continents colliding or plates sliding past one another over millions of years. These processes continue even now, though so slowly we rarely notice. As you rest tonight, picture these vast mountain ranges stretching across continents. Some peaks catch the first light of dawn while others slip into twilight. They stand patient and timeless, watching over the valleys below, just as they have for countless ages. Mount Everest, known as Sagarmatha in Nepal and Chomolungma in Tibet, stands as Earth's highest point above sea level. But this giant isn't finished growing. Each year, the mountain rises approximately 4 millimeters as the Indian tectonic plate continues pushing northward into the Eurasian plate. This growth happens so gradually that no human lifetime could witness a noticeable change. Yet over geological time, these tiny increments have built something extraordinary. The forces that created Everest began their work around 50 million years ago, when the landmass we now call India collided with Asia, crumpling the Earth upward like a slowly folding blanket. Tonight, as you drift towards sleep, consider this ancient patience. Mountains teach us that the most magnificent creations often come from small, persistent changes over vast periods of time. There's something deeply calming about processes that unfold beyond human perception, operating on nature's own unhurried schedule. Have you ever noticed how mountains seem to gather clouds around their peaks? This happens because mountains are powerful weather makers. As air masses approach a mountain, they're forced upward along the slopes. As this air rises, it cools, and the moisture it contains begins to condense into clouds and precipitation. This process, called orographic lift, means that mountain regions often receive much more rain and snow than the surrounding lowlands. The windward side of a mountain, which faces the prevailing winds, typically stays green and lush. Meanwhile, the leeward side, sheltered from moisture-bearing winds, may become quite dry, creating what's known as a rain shadow. Picture moisture-laden winds approaching a peaceful mountain range. The air rises gently, cooling as it climbs, until soft clouds begin to form. These clouds cloak the peaks in mystery, sometimes releasing gentle rain that nourishes the forests below. It's a cycle as old as mountains themselves, a rhythm of nature that continues while you rest. Not all mountains are young and jagged like the Himalayas. The Appalachian Mountains in eastern North America are among Earth's oldest mountain ranges, having formed approximately 480 million years ago. Once, these peaks may have rivaled the Himalayas in height, but time has been a patient sculptor. Over hundreds of millions of years, wind, water, ice, and chemical weathering have gradually worn down these ancient heights. What were once sharp, towering peaks have become rounded, gentle slopes covered in forests. The Appalachians today rise to modest heights, with Mount Mitchell in North Carolina reaching just over 2,000 meters. These old mountains remind us that even the mightiest peaks eventually yield to time. There's a peaceful quality to their rounded forms, as if they've settled into comfortable old age. As you settle into sleep, imagine these ancient hills, softened by eons, watching over the land with quiet wisdom. Despite covering only about a quarter of Earth's land surface, mountain regions contain roughly half of the world's biodiversity hotspots. These are areas with exceptional concentrations of species found nowhere else on Earth. From the misty cloud forests of the Andes to the alpine meadows of the Himalayas, mountains harbor extraordinary variety. This diversity exists partly because mountains create so many different habitats in a small area. As you climb a mountain, the environment changes dramatically. Warm valleys give way to temperate forests, which transition to alpine meadows, and finally to barren, frozen peaks. Each zone supports its own community of specially adapted plants and animals. Imagine a mountain clothed in life from base to summit. Near the bottom, tropical flowers bloom in humid air. Higher up, oak and pine forests rustle in cooler breezes. Higher still, hardy wildflowers dot rocky meadows where few trees can survive. At the summit, only the most resilient lichens cling to stone. Each creature and plant has found its perfect home on the mountain's slopes. Many of Earth's most beautiful mountains began their lives as volcanoes. Mount Fuji in Japan, Mount Kilimanjaro in Tanzania, and Mount Rainier in Washington state all formed through volcanic activity. These mountains were built layer by layer as eruptions deposited lava and ash that cooled and solidified over time. Volcanic mountains often have distinctive cone shapes, especially when they're young. Their slopes are built from countless eruptions, each adding another layer to the growing peak. Some volcanic mountains are still active, occasionally reminding us of the powerful forces that created them. Others have been dormant for thousands of years, their fires long cooled. Picture molten rock flowing slowly upward from deep within the earth, emerging at the surface and cooling under open sky. Layer upon layer, eruption after eruption, the mountain grows taller. Eventually, the volcano quiets, and life begins to colonize its slopes. Forests take root in the rich volcanic soil, and what was once a source of destruction becomes a source of life. Many of the world's greatest rivers are born in mountains. The snow and ice stored in high elevations act as natural water towers, gradually releasing moisture throughout the year. As snow melts and glaciers slowly flow downward, they feed streams that grow into rivers, bringing life-giving water to valleys and plains far below. The Himalayas alone feed 10 of Asia's largest rivers, including the Ganges, Yangtze, and Mekong. These rivers support billions of people, irrigate vast agricultural regions, and sustain diverse ecosystems. Without mountain snowpack storing water and releasing it gradually, many of these rivers would run dry during warm seasons. Tonight, imagine a single snowflake falling on a high mountain peak. It settles among countless others, compressed over time into ice. Eventually, warmth coaxes it to melt, and it begins a long journey downward, first as a tiny trickle, then joining other trickles to form a stream, and finally merging into a great river that flows to the sea. One snowflake among trillions, all beginning their journey from the quiet heights. While the Andes hold the title of longest mountain range on land, stretching about 7,000 kilometers, they're dwarfed by the mid-ocean ridge. This underwater mountain system winds through every ocean on Earth, extending for more than 65,000 kilometers. It's the longest mountain range in the world, yet most people never see it. The mid-ocean ridge marks the boundaries where tectonic plates are pulling apart. As they separate, molten rock wells up from Earth's mantle, cooling to form new oceanic crust. This process creates a continuous underwater mountain chain, with peaks rising thousands of meters above the ocean floor, though still far below the water's surface. Picture this hidden landscape beneath calm ocean waters. Volcanic mountains rise in the darkness, hosting strange creatures that thrive without sunlight. Hydrothermal vents release mineral-rich water, creating oases of life in the deep. It's a parallel world of mountains, as grand as any on land, waiting peacefully in the ocean's depths while waves roll overhead and you rest safely on shore. If you've ever watched mountains at sunrise or sunset, you may have noticed something magical. Mountains can cast shadows upward into the sky, creating what are called mountain shadows or shadow bands. These appear as triangular dark regions extending from the peak toward the horizon, creating striking visual effects. This phenomenon occurs when the sun is low on the horizon, positioned behind the mountain from the observer's perspective. The mountain blocks sunlight, casting its shadow onto the atmosphere itself. Particles in the air scatter light, making the shadow visible as a darker band against the lighter sky. The shadow appears to stretch impossibly far, sometimes reaching the opposite horizon. Imagine standing on a high peak as the sun sets behind you. Your mountain's shadow stretches across the sky, a dark triangle pointing toward the horizon. The air itself becomes a canvas, displaying the mountain's silhouette against the fading light. It's a gentle reminder that even shadows can be beautiful, and that endings, like sunset, often bring their own special magic. In polar regions, some mountain peaks experience phenomena called polar night, where the sun doesn't rise above the horizon for weeks or even months at a time. During these extended periods of darkness, the mountains rest in twilight or complete darkness, illuminated only by moonlight, starlight, and sometimes the ethereal glow of aurora. These dark months might seem harsh, but they have their own quiet beauty. Without daylight's distractions, the night sky reveals itself fully. The aurora borealis or aurora australis often dance above polar peaks, painting the darkness with shimmering curtains of green, purple, and red light. Stars shine with exceptional brilliance in the cold, clear air. Picture a mountain standing in the peaceful darkness of polar night. The stars wheel slowly overhead, marking time's passage. Occasionally, ribbons of aurora light ripple across the sky, briefly illuminating snow-covered slopes in otherworldly colors. The mountain waits patiently for the sun's return, resting in the quiet darkness, much as you rest now in the comfort of night. Mountains are Earth's frozen reservoirs, storing about 99% of the planet's freshwater ice outside of Greenland and Antarctica. Mountain glaciers and ice caps accumulate over years, decades, and centuries, creating vast stores of frozen water. These icy reserves release water gradually, sustaining rivers and ecosystems even during dry seasons. A glacier forms when winter snowfall exceeds summer melting year after year. The accumulated snow compresses into ice, which begins to flow slowly downhill under its own weight. Some mountain glaciers are hundreds of meters thick and have existed for thousands of years, carrying within them a record of past climates preserved in ancient ice. Imagine snow falling gently on a high peak year after year. Each layer compresses those beneath it. Eventually, the snow transforms into blue ice, so densely packed that it appears to glow from within. The glacier moves downslope at a pace imperceptible to human eyes, a frozen river flowing through the centuries, patient and powerful in its slow journey. Mount Everest may be Earth's highest mountain, but it's modest compared to Olympus Mons on Mars. This Martian volcano stands approximately 51,900 feet tall, about 2.5 times the height of Everest. It's so massive that if you stood on its summit, its slopes would extend beyond the horizon in every direction. Olympus Mons grew so large partly because Mars lacks plate tectonics. On Earth, volcanic hotspots move relative to the tectonic plates above them, creating chains of volcanoes rather than single massive peaks. On Mars, a volcanic hotspot remained in one place for billions of years, allowing Olympus Mons to grow to extraordinary proportions. Tonight, as you rest on Earth, consider mountains on other worlds. On Mars, a mountain nearly 3 times taller than Everest stands in silent, rust-colored landscape, untouched by wind or rain for ages. It reminds us that the universe is full of wonders beyond our world, each one waiting peacefully in the cosmic night, just as mountains wait through earthly nights. In certain conditions, some mountains and sand dunes produce mysterious sounds called singing or booming. This phenomenon occurs when sand or snow avalanches down steep slopes, creating low-frequency sounds that can range from gentle hums to loud booms. The exact mechanism isn't fully understood, but it likely involves the friction between countless grains moving together. Marco Polo reported hearing these sounds in the Gobi Desert, describing them as sounds of spirit drums. Local legends around the world have attributed singing mountains to spirits, dragons, or other supernatural forces. Scientists now understand these are natural acoustical phenomena, but they remain enchanting nonetheless. Picture dry sand sliding down a steep dune, countless millions of grains cascading together. As they flow, they create vibrations that resonate through the mountain, producing a deep, humming note that seems to come from the earth itself. It's a voice from the geological world, a reminder that mountains have their own ways of speaking to those who listen. Lake Tilicho in Nepal holds the record as one of the highest lakes in the world, sitting at approximately 10,000 feet above sea level in the Annapurna mountain range. This pristine alpine lake is fed by glacial meltwater and surrounded by snow-capped peaks. Few places on Earth combine such altitude with such tranquil beauty. Life is sparse at such heights. The air is thin, temperatures are cold, and the growing season is short. Yet even here, hardy organisms find ways to survive. The lake's waters support microscopic life, and in summer, a few resilient wildflowers bloom on its shores, adding splashes of color to the rocky landscape. Imagine this high mountain lake, its surface mirror calm, reflecting the peaks that surround it. The water is crystal clear and achingly cold, fed by glaciers that glisten in the sun. A breeze barely ripples the surface. It's a place of profound peace, where water and stone and sky meet far above the ordinary world, resting together in timeless serenity. Mountains might seem eternal and unchanging, but they're actually in constant motion, though far too slowly for us to perceive directly. Tectonic forces continue to push them upward while erosion wears them down. Some mountains rise a few millimeters per year, others, like some parts of the Appalachians, are actually sinking as they erode. During ice ages, massive glaciers press down on mountains with tremendous weight, actually depressing the Earth's crust beneath them. When the glaciers melted, the mountains began slowly rebounding upward, a process that continues today in some regions. Scandinavia is still rising from the removal of Ice Age glaciers thousands of years ago. Picture a mountain engaged in this slow dance of stone. It rises imperceptibly, pushed by forces deep below. Simultaneously, rain and ice carve its surface, grain by grain, carrying stone downward to the valleys. The mountain is both growing and shrinking, rising and falling, engaged in a transformation so gradual that it seems perfectly still to our brief human perception. As you climb higher in the mountains, the air becomes thinner. At sea level, the atmosphere presses down with the full weight of all the air above. At higher elevations, there's less air above, so the pressure decreases. At the summit of Mount Everest, the air pressure is only about 1/3 of what it is at sea level. This means there are fewer oxygen molecules in each breath at high altitude. Your body must work harder to get the oxygen it needs, which is why mountain climbers often feel breathless and tired. Over time, people can adapt to high altitude. Their bodies produce more red blood cells to carry oxygen more efficiently. Some human populations have lived at high altitude for thousands of generations and have developed remarkable adaptations. Imagine breathing mountain air, each breath filled with coolness and clarity. Though thinner than lowland air, it carries the scent of snow and stone and pine. Each breath connects you to the mountain, and as you breathe slowly now, let that same calmness fill you. Breathe in peace, breathe out tension, finding your own perfect altitude for rest. Ice cores drilled from mountain glaciers contain tiny bubbles of ancient air, trapped when the ice formed years, decades, or even centuries ago. Scientists can extract and analyze these air samples, learning what Earth's atmosphere was like in the past. Each bubble is a tiny time capsule, preserving a moment in atmospheric history. By studying ice cores from mountains around the world, researchers have reconstructed past climates, tracking changes in temperature and atmospheric composition. They've learned about ancient volcanic eruptions, changes in solar activity, and the composition of air before the industrial age. Mountains thus serve as archives, keeping records written in ice. Picture air from centuries past, sealed in a crystal of ice deep within a glacier. This air last moved freely when the glacier was forming, perhaps before any of today's cities existed. Now it waits in frozen suspension, preserved perfectly until scientists release it to learn its secrets. Mountains remember, keeping safe these fragments of lost time. The Alps are actually growing taller, even though they're ancient mountains that formed tens of millions of years ago. The African tectonic plate continues pushing northward into the Eurasian plate, causing the Alps to rise by about 1 to 2 millimeters per year. Meanwhile, erosion wears them down at roughly the same rate, so their height remains relatively stable. This process will continue for millions of years to come. Eventually, the Mediterranean Sea might close entirely as Africa continues its slow collision with Europe. The Alps and other Mediterranean mountain ranges may grow even higher, though this future lies millions of years ahead, almost incomprehensibly distant from our perspective. Imagine these great plates of Earth slowly converging, moving at about the rate your fingernails grow. It seems impossibly slow, yet over millions of years, this patient movement has built ranges that stretch across continents. The mountains don't hurry, they rise in their own time, teaching us that some changes, though imperceptible, are nonetheless profound and certain. Mountain peaks experience special lighting effects called alpenglow. Just before sunrise or after sunset, when valleys below are already dark, high peaks may glow with beautiful pink, orange, or red light. This happens because the peaks remain in sunlight, or catch the sun's rays, when lower elevations are in shadow. Alpenglow creates some of nature's most spectacular displays. Mountains appear to be lit from within, glowing against darkening skies. The effect can last for just a few minutes, a fleeting moment of magic that has inspired artists and mountaineers for generations. In some regions, there's even an afterglow, where peaks briefly light up again after sunset, as high-altitude particles scatter the last rays of sun. Imagine standing in a darkening valley, watching distant peaks catch the day's final light. The mountains seem to burn with gentle fire, pink and gold against the deepening blue of evening. It's a daily benediction, the sun's last kiss upon the highest places before night falls. And like sunset itself, it reminds us that day's end brings its own beauty, ushering in the peace of night. Despite mountains being ancient, the soil on their slopes is often quite young. Steep slopes and harsh weather constantly erode and transport soil downhill, preventing the accumulation of deep, old soil layers. What develops is often thin and rocky, continuously refreshed by the weathering of bedrock beneath. This young soil presents challenges for plant life, yet mountain vegetation has adapted remarkably. Many mountain plants have extensive root systems that stabilize soil and mine nutrients from rock. Some form symbiotic relationships with fungi that help them extract nutrients from poor soil. Life finds ways to thrive even where conditions seem harsh. Picture a mountain flower, its roots reaching deep through thin soil to grip the bedrock below. It blooms briefly in the short mountain summer, making the most of meager resources. Like this flower, we too can bloom where we're planted, finding strength even in challenging conditions. As you rest tonight, let go of what seems difficult, trusting in your own resilience. On calm, clear nights, mountain valleys often experience temperature inversions, where cold air sinks into the valley bottom while warmer air remains on the slopes above. This creates a layer of cold air trapped beneath warmer air, the reverse of the normal pattern where air gets colder as you go higher. These inversions can create striking visual effects. Fog may fill the valley like a river of clouds, while peaks above remain clear and warm. Valleys may freeze while slopes remain mild. In some regions, people build their villages on mountain slopes rather than in valleys specifically to take advantage of these warmer temperatures in winter. Imagine looking down from a mountain slope on a calm winter morning. Below, the valley has disappeared beneath a sea of white fog, with only the highest peaks emerging like islands. The air where you stand is clear and surprisingly mild. The mountain has created its own climate zones, each with its own character, each teaching something about the complexity of the natural world. In Tibetan Buddhist tradition and some other mountain cultures, sky burial is practiced as a way of returning the body to nature. The deceased is placed on a mountaintop where vultures and other birds consume the remains. This practice reflects a profound understanding of the cycle of life and death, viewing the body as an offering to other living beings. This tradition suits mountain environments where fuel for cremation is scarce and the ground is often too rocky or frozen for burial. It also reflects spiritual beliefs about impermanence and the interconnection of all life. The mountain serves as a bridge between earth and sky, between life and what comes after, a sacred space for transition. Picture a high mountain plateau under endless sky. Vultures wheel gracefully on updrafts, performing their ancient ecological role. The mountain witnesses this eternal cycle of life feeding life, death enabling life, everything connected in an unbroken circle. It's a reminder that endings are also beginnings, that release leads to transformation, just as sleep each night leads to awakening renewed. Mount Kailash in Tibet is considered sacred by 4 religions: Buddhism, Hinduism, Jainism, and Bon. Billions of people revere this peak as the home of deities or the center of the spiritual universe. Despite being less than 12,700 feet tall, modest by Himalayan standards, it has never been climbed, out of respect for its sacred status. Pilgrims travel great distances to walk around Mount Kailash in a ritual circumambulation, believing the journey purifies karma. The mountain's striking appearance, a symmetrical, snow-capped pyramid, has inspired awe for millennia. It stands as a reminder that a mountain's significance isn't measured only in meters, but in meaning. Imagine countless pilgrims over thousands of years, each walking the same path around a sacred mountain. Their footsteps have worn trails into stone. Their prayers have drifted up on mountain winds. The mountain receives all this devotion with perfect equanimity, neither accepting nor rejecting, simply being. In its presence, people find what they seek: peace, purpose, connection to something greater than themselves. Living in mountains has shaped human biology in fascinating ways. Populations that have lived at high altitude for many generations, such as Tibetans and Andean peoples, have developed genetic adaptations that help them thrive in low-oxygen environments. These adaptations include more efficient oxygen processing and increased lung capacity. Tibetans have a variant of a gene called EPAS1 that helps them maintain lower hemoglobin levels than would be expected at high altitude, preventing blood from becoming too thick. This adaptation may have developed in as little as 3,000 years, making it one of the fastest known examples of human evolution. Mountains haven't just shaped the land, they've shaped us as well. Think of humans adapting to life among the peaks over countless generations. Each generation passes on traits that help their children thrive in thin air. The mountains become part of human heritage, written into genes, carried forward through time. We are shaped by the places we inhabit, just as we shape them in return. Mountain goats and other mountain-dwelling animals have evolved remarkable adaptations for steep terrain. Their hooves have a hard outer rim that provides grip on rocky surfaces, while a softer inner pad acts like a natural climbing shoe. They can stand on ledges barely wide enough for their feet, and can leap across gaps that would terrify most creatures. These animals make their homes in places predators cannot easily follow. They bed down on narrow ledges and graze on slopes that seem impossibly steep. Their kids are able to walk and climb within hours of birth. Life in the mountains demands sure-footedness, and these creatures embody grace in challenging terrain. Picture a mountain goat standing calmly on a narrow ledge, completely at home in a place that seems impossibly precarious. The goat doesn't fear falling, it knows its abilities perfectly. There's a lesson here about trust in your own capabilities, trust in finding your footing even on difficult paths. Sometimes the key to peace is simply knowing you're equipped for whatever terrain you're crossing. In mountainous regions, you might witness a rare phenomenon called a Brocken spectre or glory. This occurs when your shadow is cast onto clouds or fog below you, and atmospheric conditions create rainbow-colored rings around the shadow. It's named after Brocken Peak in Germany, where it's often observed. This optical effect happens when sunlight behind you reflects off water droplets in the mist ahead. The shadow of your head appears magnified and sometimes seems to move independently, surrounded by glowing colored halos. Early observers, not understanding the phenomenon, sometimes interpreted their own magnified shadows as supernatural beings or divine visitations. Imagine standing on a mountain ridge with sun behind you and mist ahead. You look down and see your shadow stretching across the clouds, surrounded by shimmering rings of rainbow light. For a moment, you appear to be standing among the elements, neither fully in earth nor sky, witnessed by your own luminous presence. It's a reminder that we each carry our own light, even when we can't always see it ourselves. On every mountain, there's an elevation above which trees cannot survive, called the tree line or timberline. This boundary occurs at different elevations depending on latitude and local conditions, as low as sea level in polar regions, around 6,000 feet in the Alps, and above 8,500 feet near the equator. Above the tree line lies the alpine zone, where only low-growing shrubs, grasses, and wildflowers can survive the harsh conditions. These plants grow close to the ground, where they're protected from wind and retain more warmth. Though small, they're remarkably tough, blooming in brief mountain summers and surviving conditions that would kill most other plants. Picture the tree line, the last brave trees clinging to thin soil, bent and twisted by wind, gradually giving way to open meadows. Above them, only small flowers and grasses persist. It's a visible reminder that every organism has its limits, its boundaries. There's no shame in reaching your own limits. Sometimes recognizing where you can grow and where you cannot is wisdom, not weakness. Rest where you are. Mountains create spectacular echoes due to their large, hard rock faces that reflect sound waves. In some mountain valleys with the right geometry, you can hear echoes lasting many seconds, with your voice bouncing back to you again and again. Some valleys are known for producing multiple distinct echoes from different rock faces. The physics is simple, sound waves bounce off rock much as light bounces off a mirror, but the effect can be magical. Mountain dwellers throughout history have made use of echoes, using distinctive calls to communicate across valleys. The phenomenon has also inspired countless stories and legends about mountains answering back to those who call out. Imagine calling out in a mountain valley. Your voice travels across open space, strikes a distant cliff, and returns to you. Then another echo arrives, and another, each one softer, until the sound fades completely into silence. Your voice is both sent and received, traveling out and returning. Perhaps this is a metaphor for communication itself. What we send into the world eventually returns to us, transformed by its journey. Mount Paitu, on the border between North Korea and China, has a caldera lake at its summit called Heaven Lake. This crater lake formed in the depression left by ancient volcanic eruptions. Despite being at high elevation, the lake is nearly 5 kilometers wide and quite deep, a mysterious body of water crowning the mountain. Crater lakes form when volcanic craters fill with rain and snowmelt. The water can be remarkably blue and clear, surrounded by the remnants of volcanic rock. These summit lakes seem especially magical, secret pools in the sky, accessible only to those who make the climb, places where water and mountain merge. Picture a lake at the top of the world, its water blue as evening sky. The mountain holds this water carefully, a gift from clouds and snow. The lake reflects passing clouds and circling birds. It's peaceful beyond measure, water that has climbed as high as water can climb, resting in a stone bowl, waiting patiently for evaporation to lift it even higher, back to the clouds from which it came. All mountains, even the mightiest, are temporary on geological timescales. The Appalachians, once perhaps as tall as the Himalayas, have been worn down to modest heights. The Himalayas, despite still growing, will eventually stop rising and begin the long process of erosion. Given enough time, hundreds of millions of years, even Mount Everest will be worn away to nearly flat land. This perspective is both humbling and strangely comforting. Nothing is permanent, not even mountains. Yet in their impermanence, mountains teach us about persistence. Though they're slowly disappearing, they stand for millions of years, longer than we can truly comprehend. They change so slowly that to us they seem eternal, which is a kind of truth in itself. As you drift towards sleep tonight, carry this thought: mountains rise and fall, appear and disappear, all in nature's time. You too are part of this flow, rising and resting, waking and sleeping, growing and changing. There's no need to resist the natural cycles of existence. Like mountains, simply be present for as long as you're here, standing with whatever grace you can muster, then letting go when it's time. We've journeyed through 30 facts about mountains, from their heights to their depths, from their births to their eventual disappearance. These ancient peaks have much to teach us about patience, persistence, and peace. As you rest now, perhaps you'll dream of mountains, their quiet strength, their peaceful permanence, their slow dance with time and weather. Let these images carry you into deep, restful sleep. Good night, and may your dreams be as peaceful as a mountain meadow on a calm summer evening.